Girih tiles are a set of 5 tiles that were used in the creation of Islamic geometric patterns using strapwork, Girih, for decoration of buildings in Islamic architecture. They have been used since about the year 1200 and their arrangements found significant improvement starting with the Darba Imam shrine in Isfahan in Iran built in 1453. 5 tiles The 5 shapes of the tiles are: a regular decagon with 10 interior angles of 144 degrees, an elongated, irregular convex hexagon with interior angles of 72 degrees, 144 degrees, 144 degrees, 72 degrees, 144 degrees, 144 degrees, a bow tie, non-convex hexagon, with interior angles of 72 degrees, 72 degrees, 216 degrees, 72 degrees, 72 degrees, 216 degrees, a rhombus with interior angles of 72 degrees, 108 degrees, 72 degrees, 108 degrees, and a regular pentagon with 5 interior angles of 108 degrees. All sides of these figures have the same length, and all their angles are multiples of 36 degrees, pi, 5 radians. All of them, except the pentagon, have bilateral reflection symmetry through 2 perpendicular lines. Some have additional symmetries. Specifically, the decagon has 10-fold rotational symmetry, rotation by 36 degrees, and the pentagon has 5-fold rotational symmetry, rotation by 72 degrees. Girih Girih are lines, strapwork, which decorate the tiles. The tiles are used to form Girih patterns, from the Persian word, meaning knot. In most cases, only the Girih, and other minor decorations like flowers, are visible rather than the boundaries of the tiles themselves. The Girih are piecewise straight lines which cross the boundaries of the tiles at the center of an edge at 54 degrees, 3 pi, 10, to the edge. 2 intersecting Girih cross each edge of a tile. Most tiles have a unique pattern of Girih inside the tile which are continuous and follow the symmetry of the tile. However, the decagon has 2 possible Girih patterns, one of which has only 5-fold rather than 10-fold rotational symmetry. Mathematics of Girih tilings In 2007, the physicists Peter J. Liu and Paul J. Steinhardt suggested that Girih tilings possessed properties consistent with self-similar fractal quasi-crystalline tilings such as Penrose tilings, predating them by 5 centuries. This finding was supported both by analysis of patterns on surviving structures, and by examination of 15th-century Persian scrolls. However, we have no indication of how much more the architects may have known about the mathematics involved. It is generally believed that such designs were constructed by drafting zigzag outlines with only a straight edge and a compass. Templates found on scrolls such as the 97-foot, 29.5 meters, long Topkapi scroll may have been consulted, found in the Topkapi Palace in Istanbul, the administrative center of the Ottoman Empire and believed to date from the late 15th century. The scroll shows a succession of 2- and 3-dimensional geometric patterns. There is no text, but there is a grid pattern and color coding used to highlight symmetries and distinguish 3-dimensional projections. Drawings such as shown on this scroll would have served as pattern books for the artisans who fabricated the tiles, and the shapes of the Girih tiles dictated how they could be combined into large patterns. In this way, craftsmen could make highly complex designs without resorting to mathematics and without necessarily understanding their underlying principles. This use of repeating patterns created from a limited number of geometric shapes available to craftsmen of the day is similar to the practice of contemporary European Gothic artisans. Designers of both styles were concerned with using their inventories of geometrical shapes to create the maximum diversity of forms. This demanded a skill and practice very different from mathematics. Examples Different patterns. See also Aperiodic tiling. Penrose tiling. Roger Burroughs, author of coloring books based on Girih tiling. Zelija. References External links Girih tiles and Islamic geometric designs in modern architecture. Browser-based Girih tiling editor. John Savard's Reconstructions. Medieval Islamic architecture presages 20th century mathematics. Harvard University Gazette. The 22nd of February 2007. Retrieved the 14th of March 2007. Medieval Islamic tiling reveals mathematical savvy. New Scientist. The 22nd of February 2007. Retrieved the 14th of March 2007.